Hello, good evening. Watch this video first. This will create an impact on your minds. Look at this devastating system. Think of the magnitude and the intensity of this meteorological system, which is actually a low pressure system with hurricane winds and the swirling clouds, lightning, thunder.
Introducing another innovation from the house of Alok.
Oh, it just got interrupted because of the ad.
A one-stop kiosk for all sanitation products.
I still want you to see this video because this video actually we have received from certain place. We searched on internet only, but this was simply amazing. This is about the cyclone formation. Just watch it. This is a stunning satellite view of the hurricane. Look at the swirling clouds, and the satellite map is showing a number of cyclones which are produced in different oceans. Oh my God. Just look at the eye, that center, and the swirling clouds again. How it moves on the ocean surface. And you can see that number of cyclones are born together and they move in a particular direction. All these cyclones are moving towards west because they are driven by the trade winds, which are generally easterlies. There are certain exceptions to this rule, which we will discuss in our classes. If this cyclone is going to move on the land, it is going to devastate. It has this suction effect which can pluck and lift anything in the air and can turn things into pieces. Now look, this cyclone is approaching Florida, above Florida. And is going to hit the land now. It has entered the land. When it enters the land, it must die. Why it must die? Because the supply of the moisture, supply of water vapor is restricted. And once the latent heat from the water vapor is not available, the cyclones are going to die. But before the death, they bring devastating phenomena. I was really impressed with this particular video from the internet which I collected from a particular site. I hope you enjoyed that video. I'm still learning the technicalities of all this, but I hope everything will be all right. सुपर साइक्लोन क्या है और सुपर साइक्लोन का ओरिजिन कैसे होता है? सुपर साइक्लोन का मैकेनिज्म क्या है? Since currently we have one super cyclone coming over the land, and your IMD also declared it as a super cyclone. So I think it is very important for your examination, maybe for the geography option also, maybe for your prelims also, for GS also. maybe interviews also. It will be a short video. I mean, explanations will be limited because time is limited. Now, coming to the point, super cyclone is a tornado of bigger size but greater intensity. Tornadoes are the smallest and the most devastating cyclonic systems. Now, super cyclone and tornado, their origin is more or less the same. They originate due to the similar conditions more or less. But when the tornadoes are increasing in magnitude, जब tornado का size बड़ा होने लगता है, and they gain more energy from the water vapor which they collect when they start running over the surface of the ocean. और जब उसके पास वाटर वेपर का लैटेंट हीट का एक बड़ा कलेक्शन हो जाता है, तब वो एक डिवास्टेटिंग सिस्टम में ट्रांसफॉर्म होगा. और हम लोग 3 पॉइंट पे कंपैरिजन करते हैं. 3 पॉइंट जनरली लोग जो साइंटिस्ट हैं वो कंपेयर करते हैं. नाउ व्हाट आर दिस 3 पॉइंट्स? फर्स्ट इज द वेलोसिटी. जनरली a cyclone, a normal cyclone will have a velocity of 65 miles, or as Wikipedia says 74 miles or 119 kilometers per hour. But the super cyclone will have a velocity of almost double of the cyclone, double of the tornado. Now, super cyclone will have a velocity maybe 150 miles per hour or maybe 220 kilometers per hour. Different facts could be found in different literature. IMD has some different criteria and the NASA has some different criteria. So it varies from books to books, from material to material. Overall, the intensity, magnitude, velocity of the super cyclone will be almost twice of a tropical cyclone. This is the first difference. Now, second difference is the eye of the cyclone, eye of the super cyclone is narrower than the normal cyclone. Why it is so? Because the intensity of the swirling winds is so intense that the air actually could reach the center. Generally in cyclones, the center has subsidence of air. Even super cyclone will have subsidence of air. Generally we believe that the cyclone center is having low pressure. No, these cyclones have relatively higher pressure at the center, because the suction effect is taking place as the air is lifting from the eye, and there has to be some kind of compensation from the top. So this compensation from the top creates actually a certain degree of higher pressure at the center. Now, I gave 2 comparisons. Now, third one is about the upsurges which they produce in the sea water. What are upsurges? When the cyclones are moving on the surface, they lift the sea water and the standing waves are created. Standing waves or the vertical waves are created. And these vertical waves keep traveling along the surface. And as they approach the shore, the depth of the water is less. So the oscillatory motion which is below the waves will be restricted, will be obstructed by the lesser depth. And as the friction is growing, the verticality of the wave keeps increasing. And when the waves are more vertically rising, these surges will be like the heaving giant of water approaching the coast, and this is actually dreaded, and this is highly devastating. The height of the surges will be 20 feet in a super cyclone, but in general cyclones or a tornado, the height of the upsurge will be around 14 feet. So there is a difference in terms of the upsurges which they create. Now, the fourth difference is that the flood water, as a super cyclone hits a place, it stays for almost 1 or 2 hours. It stays longer than the normal cyclone, but the normal cyclone will move in say 20 minutes, 30 minutes, it keep moving, but super cyclone stays there for a while because of the bigger size of the larger diameters of the eye wall. So it stays there for a while. Now, since we have discussed 3-4 comparisons, but I would like to add 2 more. The height of the super cyclones are also much greater than the normal cyclones. The height could be 14 kilometers because the troposphere is 16 kilometer. The tropopause is near 16 kilometer. So their height could be 14 kilometers. But a normal cyclone will have a height 8 to 12 kilometers. So their height is more. They are more dreaded. They are more devastating. They are more furious. They have more rainfall. They can create flood water. Another comparison. They create flood water up to the height of 20 feet. So 20 feet building could be submerged underwater when the super cyclone hits. And super cyclone is a phenomena which often repeated after a gap of 20 years. This cannot be the rule, but generally it has it first came in 1970s, which was observed. It again came in 1990s also. Then it is coming in 2020s. After a gap of a decade almost, these super cyclones are generally found. They are very rare of their own kind. They are very rare species of cyclone, which are rarely created, which are seldom found. Now, why they are created and how they are created, I have a simple model for you, which I have to take up in few minutes. So here I go. Look, say this is your coastline. This is your Florida and the coastline. And this is your Caribbean Sea. Now, Caribbean Sea has several islands. Now, these islands are heated directly by the tropical sun or the high sun. During the summers, especially in the month of June, when sun is overhead the Tropic of Cancer. So once it is over Tropic of Cancer, the direct sun rays are hitting these islands, a speck of these islands. Now when these islands are heated, this is all water, and this island. So these islands will develop low pressure. This is the low pressure development. So these are the low pressure areas which are developing because of the excessive heating of the terrestrial land. Now this concept will be discussed with the फिजिक्स से एक्सप्लेन कर सकते हैं इसको कि स्पेसिफिक हीट पानी का ज़्यादा होता है, स्पेसिफिक हीट ऑफ वाटर इज मोर देन लैंड. तो दिस विल बी हीटेड मोर, एंड एज इट इज हीटेड मोर द एयर विल बिगिन टू राइज. द एयर हैज बिगिन टू राइज. द एयर विल बिगिन टू राइज, एंड एज द एयर इज राइजिंग, look, the air is rising, low pressure will further deepen. And as the low pressure deepen, it will begin to attract air from the lateral areas. The lateral flow of air has begun. The horizontal flow of air has begun. Now, this convergence of air is further strengthening the lifting of the air. Now, the water vapor is being transported in the upper troposphere. When it is being transported in the upper troposphere, this air above the line of condensation will form these black clouds full of rain. Nimbus clouds, or maybe cumulonimbus clouds are formed. So here you have the formation of the cumulonimbus clouds. Now these are typically the thunderstorms. So a number of thunderstorms are produced over the peak of the islands, over the top of the islands. Now when these islands have developed thunderstorms and maybe the trade winds are prevalent and trade winds are accelerating. So if the trade winds are accelerating, all these number of thunderstorms will begin to converge along a certain low pressure vortex. This is a low pressure vortex which are naturally developed over the ocean surface. Now all these are attracted. Now this vortex can be formed in ITCZ also, intertropical convergence zone also. So all these thunderstorms are transported into the ITCZ, where there is a pre-existing vortex or a trough, and they enter. If their progression is symmetrical, then all will converge in the vortex and they will join to form a much stronger or a nascent cyclone, or a much stronger thunderstorm or a nascent cyclone, and the vortex also intensifies. Now, as the vortex has started traveling along the surface, if this vortex has got all the thunderstorms together and it has started traveling, it will collect more moisture from the ocean. Now, there are three very interesting conditions for the formation of supercyclone here. Now, that is where we will differentiate from how a normal cyclone is created and how a supercyclone is created. When we have a dual channel outflow, the supercyclones are created, and when we have a general upper air outflow, cyclones are created. Now, what is dual channel outflow? It has been observed that this rising air, when it loses its moisture and sheds its moisture, it becomes dry and cold. And when it becomes dry and cold, this cold air creates a kind of wave. It creates a kind of wave, upper air wave, in this fashion. These are dual channel outflow. Two meandering outflows layers are found. I'm not able to create it on the diagram because of this congestion, but simply remember these two outflows are meandering and also rotating, revolving. Now, these two outflows creates massive fall in the pressure at the center of this vortex, and the pressure will further deepen in the vortex. Now, as the pressure is deepening, it collects more air, more moisture from the surrounding. And when in the normal cyclone, the upper air flow is something like this. There is the convergent air, there is the rising air, and this is how the upper air circulation will be. So it enters, rises, and it flows in all the direction. That's a cyclone. But in supercyclone, you have this dual outflow. It rises and the two waves are generated, meandering waves are generated, and it keeps rotating also. So this has been noticed by the satellite, and the scientists have written on this particular phenomena, which is special to the supercyclones. Now, second major cause behind the formation of the supercyclone is they must enter an area which has enormous amount of moisture, and maybe the relative humidity shall be around 99%, and this is found along the tropical sea. So if it enters the moist area with 99% RH, relative humidity, it will suck more moisture, and when it sucks more moisture, it lifts, the energy is more, so lifting is more, so the convergence is more, and finally it becomes a very devastating system with the wind velocity increasing, ever increasing. And when the wind velocity is increasing, it may reach almost 240 kilometers per hour, and sometimes even more. The velocity in the eye, along the eye, the boundary which limits the eye, could be around even 350, and some scientists have also observed that in the past the 620 kilometers per hour velocity also have been found. So these facts are absolutely stunning. And we have this Katrina in 2005, which was a super cyclone. We have Angel 1992 as a super cyclone, and the Katrina ka jo velocity tha, that was 150 miles per hour. And we also calculated in terms of knots also. Knots is a nautical mile. So 120 knots could be the velocity of these super cyclones. And another condition which I want to add for super cyclone is that the trade winds which are driving these cyclones from east to west The cyclones are always going to hit the eastern margins of the continent. Why it is so? Because the trades are blowing from east to west, or rather northeast to southwest in the northern hemisphere. So they are being driven towards the eastern coast, and as they move, they have a general trajectory towards the pole because of the Coriolis effect. So Coriolis keeps rotating them. It is anti-clockwise in the northern hemisphere. So because of the anti-clockwise motion, it curves towards the pole. The cyclones never move towards the equator. Even though the trades are driving the air or the circulatory pattern, guiding the circulatory pattern towards equator, the cyclones actually turn away from the trade wind's direction, and they go towards the pole because of this curvature. Now, because of this torque also, because of the torque which is produced by the Coriolis force. Now, as they are moving in this direction, they will reach the land and they will create their devastation. Now, one more point I would like to add for the formation of supercyclone, which is the most important point, is the wind shearing effect. When a supercyclone is created, like in this cyclone, there still could be wind in the middle troposphere, and the airflow is maintained in the middle troposphere. Horizontal air motion is still found in the middle troposphere, something around 3 to 5 to 6 kilometers from the sea level. Now, as this air is maintained, the lifting capacity or the suction effect is restricted. So these normal cyclones are not so devastating. Now, in the supercyclones, this wind shearing effect is negligible. There is no such lateral motion of the wind in the middle troposphere. So when these winds are absent, the eye can further grow. This eye can grow, and you will have more lifting of air from the surrounding region, and the size of the cyclone also grows. So wind shearing effect is another condition. What is wind shearing effect? Maybe I will be talking at length in my normal course classes, but on these live videos, it is even time constraint is there, and people always suggesting me that all these videos shall not be longer than 20 minutes. So I'm really trying to hurry up with things. Wind shearing effect is the shearing, meaning, like I can explain with an example. In a pipe, when the water is moving, the central water moves faster because it has less of friction from the surrounding. So when you have less of the friction, the shearing effect is less, and when you have more friction from the surrounding, shearing effect will be more. This for the layman and for a non-geographer, for a student who has started his geography recently, not really known to the physics and the concepts of physics. So this is your supercyclone. Now, to sum up things, in supercyclone, I talked about why they are formed. Because of A, wind shearing effect is negligible, that lateral motion is negligible. B, the enormous amount of moisture which shall be available when the vortex is traveling on the sea surface. C, the convergence is stronger, lifting is stronger. And D, the dual channel outflow. The dual channel outflow which I created here, the dual channel outflows. So all these, because what happens in dual channel outflow, that when the air is lifting and the air is moving rapidly away, then it creates the lower pressure even more. So that is what is the supercyclone. It is more devastating than normal cyclone, as I told you. Now, I hope you understood few things about supercyclone, and whenever I am coming next with my classes, I am surely going to explain it in a much bigger way, with more simplicity, and with better diagrams, and with greater ease than I had today. Thank you for the day. Thank you.